All right, class, welcome. Today we're going to dive into something really cool, a super powerful tool in machine learning called regression. Basically, it's how we teach computers to find hidden patterns in data, which, lets us make some pretty smart guesses about the future.
So to get our heads around this, let's start with a fun, practical question. How can we predict the price of a pumpkin? Imagine you're a pumpkin farmer. You know prices go up and down, right? But how do you know exactly what to charge on, say, October 15th versus November 5th? How could we figure that out?
Well, to answer that pumpkin question, we need a tool that can look at all our past sales data and spot the relationship between the day of the year and the price. And that tool, you guessed it, is called regression. You can think of it as a fancy way of connecting the dots in our data.
Okay, so where do we start? With data. Always with data. Let's imagine we've got a big spreadsheet, and on that spreadsheet, for every single pumpkin package we sold, we wrote down two things: the day of the year it was sold and the price it sold for. That's it. Two columns of numbers.
So what does regression do with all this data? Well, it's kind of like a detective. It's searching for a mathematical formula, but don't get scared by that word. Just think of it as drawing a line, a trend line, that best fits the general pattern of our data points. This line is the secret sauce. It shows us the relationship between the day and the price.
So, what's the whole point of this? What's our goal? First, we want to figure out the relationship, right? Day of the year versus price. Then, regression helps us create a formula that basically is that relationship. And here's the magic part. Once we have that formula, we can use it to predict the price for any day, even days we haven't gotten to yet.
All right, let's dive into our first and maybe most common type of regression. It's called linear regression, and it's all about the straight line.
So, linear regression does exactly what the name implies. It takes all our data points, all those pumpkin sales scattered on a graph, and it draws the best possible straight line right through the middle of them. It's like finding the perfect ruler to show the general trend, a trend where the price goes up or down at a nice steady pace.
Okay, so how does this actually work for prediction? It's super simple. We want to predict the price, right? So we just give the model a day of the year. Let's say day 250. The model just looks at that day on the chart, goes straight up until it hits our line, and then looks across to see what the price is. Boom, that's our prediction.
Now, a straight line is great and all, but is the real world always that simple? Think about it. Do pumpkin prices really move in a perfect straight line all year? No way. They probably shoot up in October and then crash in November. A straight line isn't going to capture that curve, is it?
And that's where our next tool comes in. For those more complex, curvy trends, we use something called polynomial regression.
So, what's the big difference? Look here. Linear uses a straight line. Polynomial uses a curved line. It's like we're trading in our straight ruler for a flexible one that can bend. The formula is a bit more complicated. It has things like squared numbers in it, but that's what gives it the power to fit those curvy patterns in the data. And by adding that curve, our prediction line can now hug the data much more closely. It can actually show those ups and downs, like the big price spike before Halloween and the drop right after. It just gives us a much better fit for what's really happening.
Okay, so everything we've talked about so far has been about predicting numbers. A price, a temperature, a score. But what if we want to predict a category? Like not how much, but which one? That's a whole different ballgame.
Let's switch things up. Forget about price for a second. Let's say we want to predict a pumpkin's color based on its size. So the answer isn't a number anymore. The only possible answers are orange or white. See the difference? We're predicting a label, a category.
This table makes it super clear. When you want to predict a number, like a price, you use linear or polynomial regression. But when you want to predict a category, like a color, that's a job for a different tool called logistic regression. Simple as that.
So how in the world does this work? It's actually pretty clever. Here's the breakdown. You give it a pumpkin's size. Now, the model doesn't just spit out orange or white. Instead, it calculates a probability. Like, okay, based on this size, there's a 70% chance this pumpkin is white. Then, we just have a simple rule. If the probability is over a certain point, let's say 50%, we predict white. If it's under 50%, we predict orange. It's all about probability.
All right, that was a lot of information, I know. So let's pause and do a quick recap of the most important things we've learned.
So, here are our three main tools. You got linear regression. That's for predicting a number using a straight line. Then you got polynomial regression. That's for predicting a number, but with a curved line for more complex data. And finally, logistic regression.
This one's the odd one out. It doesn't predict a number at all. It predicts a category by using probabilities. Got it?
And that's really the big picture here. This isn't just about pumpkins, obviously. You can use these exact same ideas to predict just about anything. Housing prices, stock market trends, even whether an email is spam or not. So the real question I want to leave you with is this. Now that you know the tools, what patterns would you want to predict in the world around you? Think about it.